All right, so now we're going to be solving for parts in a right triangle. But when I say to solve a right triangle, what that means is to find all the missing angles and side lengths in your right triangle. Now, when we have a right triangle with two side lengths, for example, like this down here, to find the third side length is easy because we can just use the Pythagorean theorem. But in number 49, we only have a triangle with one side length and an angle measure. We cannot use the Pythagorean theorem to help us find side length DF. We need to use trigonometry. So to find side length DF, I'm going to label it X. I'm going to look at the angle that I'm given in this triangle, which is this angle here. In relation to that angle, I have the opposite side, and I'm trying to find the hypotenuse. The ratio of opposite to hypotenuse is sine. So I'm going to set up my equation. I want the sine of this 51-degree angle to be equal to the ratio opposite over hypotenuse. And now I'm going to solve this equation for X. So what that would mean is I would multiply both sides by X to get X out of the denominator first. So now I have an X times the sine of 51 is equal to 17. Now to get X by itself, it's being multiplied by the sine of 51. So we are going to divide by the sine of 51. So I wind up with X being approximately equal to, I'm going to show you how to type this into your calculator. So what you would do is you would type in 17 divided by, just like that. And then you would type in the sine of 51, just like that. Sorry, I know there's a glare. There we go. And you just hit equals. And then it does say to round to the nearest hundredth, so 21.87 would be your answer. Now, I only asked you to find DF, but if it's said to find or to solve the right triangle, that means to find all the missing angles and side lengths. For this one here, to find this other missing angle would be super easy because it's just the triangle sum theorem. 180 minus 90 minus 51. And you would wind up with 39 degrees. If I asked you to find the other side length, you would use trigonometry with this 51-degree angle. And you would do tangent because we have this, the opposite side, and we would be trying to find the adjacent side. I'm not going to have you find that side length though, because we're not solving the right triangle. We're just going to move on to number 50. Number 50 asks us to find ST, and sorry, S got cut off, it's up here. So I'm going to label ST as X, and then using the angle that I was given, X is the adjacent side, and we're given the hypotenuse. So the ratio adjacent over hypotenuse would be cosine. So I'm going to do the cosine of that 42-degree angle, and that would equal my adjacent over my hypotenuse. This time X is in the numerator, so it's pretty simple to get X by itself. I would just multiply both sides by 9.5. And so I get X to be approximately equal. I'm going to show you how to type this into your calculator. So you would type in a 9.5 times the cosine of 42. So you just hit the normal cosine button, and then you type the 42 after. And you hit equals, and you get about 7.06 rounded to the nearest hundredth. And sorry, I didn't put my units on the last one. The units on the last one was meters. This one's inches. Okay, looking at my next one, I'm trying to find BC. So I'm going to label BC as X using the angle that I'm given. I have the opposite leg, and I want to find the adjacent leg. Opposite over adjacent is tangent. So I'm doing the tangent of that 18-degree angle is equal to 12 over X. X is in the denominator, so I'm going to multiply both sides by X to get it out. Whoops. So I wind up with X times the tangent of 18 is equal to 12. And then I'm going to divide by the tangent of 18 to get X by itself. And I wind up with X is approximately equal to, if we do 12 divided by the tangent of 18 in our calculator, we get about a 36.93 feet. Again, if I asked you to solve this right triangle, you would need to find everything in the right triangle. But here I'm only asking you to find specific parts. So number 52, it says to find JL. L got cut off, it's right here. So I'm going to label JL X in relation to my 27-degree angle. X is the opposite, and we have the hypotenuse. Opposite over hypotenuse is sine. So I'm going to do the sine of the 27-degree angle, and that would be equal to X over 13.6. To get X by itself, I'm going to multiply by 13.6 on both sides. And I wind up with X is approximately equal to, typing into my calculator a 13.6 times the sine of 27, I would wind up with a 6.17 centimeters. All right, for 53 and 54, it says to find the angle measure. We're going to round to the nearest whole number. Remember, if I asked you to solve this right triangle, we could use the Pythagorean theorem to help us find this side. But I didn't ask you to solve the right triangle. I'm asking you to just find the angles. When we find angles, we use the inverse sine, cosine, and tangent. So, looking at angle X, the one that we're trying to find, I have my adjacent side and my hypotenuse. So this is cosine. I'm going to do the inverse, or I'm going to say that X equals, so the angle measure equals the inverse of cosine, and the cosine ratio is adjacent over hypotenuse. It does say to round to the nearest whole number, so I'm going to show you how to type this into your calculator. So we would do the second button, then we would type in the cos button, cosine. So you wind up with this, and then 3 divided by 7, like so. When you hit equals, rounded to the nearest whole number, you get it's about 65 degrees. Now, if I asked you to find the other angle, you would just then use the triangle sum theorem with that 65-degree angle. Like we're going to do that for number 54. We're going to find both angles. I'm going to first find angle T. I'm going to label that X. So X at angle measure would be equal to, in relation to X, I have my opposite side and my hypotenuse. Opposite over hypotenuse is sine, but if I'm finding an angle measure, I'm going to use the inverse of sine. And I'm going to use the ratio opposite over hypotenuse. I'm going to show you in my calculator how I'm going to type that in. I'm going to hit the second button, and I'm going to hit the sine button. So I have this. It should be sine to the negative first power, which is called the inverse sine. And then I'm going to type in 5 divided by 5.7. So you should have this in your calculator. And then hit equals. Rounded to the nearest whole number, we get 61 degrees for angle X. Now for angle Y, it's still an estimate because it's based off the rounded version of X. I'm just going to do 180 minus 90 minus that 61-degree angle to get 29 degrees. If I asked you to solve this right triangle, you would also need to find the side length, and you could do that by using the Pythagorean theorem. Whenever you have two side lengths, you can just use the Pythagorean theorem to find the third side length. But again, like up here, if you only have one side length and an angle measure, you need to use trigonometry. If you're ever finding an angle measure, you need to use trigonometry. All right, that brings us to the end of this trigonometry lesson.